2.4, and just page 77 there where it talks about solving the problems. There's a caution at the top. It says both the angle of elevation and angle of depression are measured between the line of sight. So usually you start horizontally and either go up or down from there. That's all they're telling you. And then it tells you to sketch a graph, you know, and label the parts that are given to you when you're trying to do word problems. And then use it to try to develop an equation and then solve the equations. So they're emphasizing to you that, you know, it's the use of drawing the picture out of what you're trying to do is going to be quite important. And let's look on page 79, number 10. And it's the instructions are, it says each right triangle, when two sides are given, give angles in degrees and minutes. So they're saying that in these problems that when you don't have an angle given, and so you don't know whether you're doing decimal degrees or degrees and minutes, do degrees and minutes. The first problem there that we're going to look at gives us a right triangle. And this is the right angle. And then they're labeling it out A, B, C. And usually 99% of the time C is always going to be the right angle. And then they're labeling the C 35.9 kilo. This angle is 31 degrees, 30 minutes. So we're supposed to figure out what C and B are, and then another thing you always want to do is use only the given information. Don't use a calculated value to calculate another one. That is, don't find this side and then use C squared equals A squared plus B squared to figure out the other ones. Just use always this information. Now, you have this angle, you have the opposite side, and they want to know the hypotenuse, and then they want to know the adjacent. So depending on which one we're going to go for first, if we're going to calculate C, then the appropriate trig function would be what? Sine of this angle is equal to opposite over hypotenuse. The appropriate trig function would be sine of an angle equals opposite over hypotenuse. So that it would be the sine of 31 degrees, 40 minutes, is going to equal 35.9 over C. And then we want to solve for C. So we're going to multiply both sides by C, so we'll get C here equals 35.9 over the sine of 31 degrees, 40 minutes. Everyone understand?
No, not like, so you multiply both sides by C?
Yeah, what I'm doing, I'm just going to do it in red. I multiplied by C and C, right? That's on an equal sign, that you multiply the same number times both sides. So this goes out. And then I'm dividing both sides by the sine.
Okay.
And then this sine of 31 degrees, 40 minutes is just a number. And then that's what I get is this value right here. Then I'm just ready to go use my calculator. And what did we say we should always do? Always start out by doing sine of 90. And what do we know? What do we know we have to do? we have to change the mode to, this has to be 1 for us to have this degrees. So we want to change this mode over so that we have it in degrees. Otherwise, we have to write degrees every time. We could do that, but all these problems are not going to be using radians. So the best thing to do is to set yourself up with that. Then we want to get ourselves back to our main screen. We just second quit out of it. And then we'll just go 35.9 and divide it by sine of 31. Now, because we're having to deal with minutes, we have to force degrees in. I'm ready to calculate that, and it says 68.38. Now, if you want to do accuracy, there's 35.9 is 3 significant digits, and it's telling it told you back here that if you have degrees and minutes to the nearest, to the nearest minute, and that's what we have, it's 4 significant digits. So this right here is 4 significant digits, this is 3. So the answer, we can go to 3, right? So we go 68.4. Because the minimum number of significant digits is all you can go to. Now, if we're going to calculate the other value, C. Now, don't do cosine B over C, because C is a calculated value, because we rounded it off. So what you want to do is use this value and this. So what would we have to do to use this angle, that side, and this side? This is the opposite. This is adjacent. So what would we do? We do tangent, right? We do this tangent of an angle is always opposite over adjacent. And how you figure it out, you just say that I know the opposite, I know the angle, and I'm trying to calculate the adjacent. So in order to use that information, we're going to have to use this particular function. Then you just insert the values. And reason we're going to go with tangent is because all we have on our calculator is sine, cosine, and tangent. So it's 31 degrees, 40 minutes. And opposite was the 35.9. And the adjacent is B. So we're going to do the same thing. B is equal to 35.9 over tangent 31 degrees, 40 minutes. Is everyone good with that? You see that one, James? Yeah. Just like before. Okay, so we'll do the 35.19. we're at 58.2. And this is kilometers. That was the same thing with this. This was kilometers. So there should be our two answers. I'm going to do 16 because it gives us a, notice it gives us the two sides. So this is a right angle, CB. Now we're going to have to calculate this angle and this angle. Oh, by the way, I think this one here, we can calculate this angle up here, which I didn't do. You did.
It says on two sides are given, find angles, but we solve for distance.
Well, they said do the angles in degrees and minutes. So the reason I'm doing this problem is that we're given the sides. So we're going to have to find this angle and that side. So we want to do this angle in degrees and minutes and this in degrees and minutes, not in decimals. That's what it's telling. So we're not given. I didn't finish this previous problem because I should have calculated this angle. And that angle B, you know, the measure of angle B is actually going to be 90 degrees minus the 3140. Because see, they've given us this angle, this side. And then we should have, which we did, we should calculate those two sides and then that angle. So I'm just going to subtract this 31 degrees, 40 minutes from that. And we have to borrow 1 degree, 89 degrees, and then this is 60 minutes. So that gives us 20 minutes. And 8. So that angle should be 58 degrees, 20 minutes. That's what this angle should be right up here. Now then we have calculated every other unknown. I neglected to do that angle. But now on this one, what we're going to do is do this side. Well, we can actually use the Pythagorean theorem, right? We can do b squared plus this squared plus that. You know, this one plus this one equals that one squared. That's allowable. And then we'll do the angle A, and then we'll do angle B, given this information. We have to get the side given the information that we have. This side B, we can't calculate this angle and then do the calculate this side by using the cosine of that angle, because this is a calculated value. In order to calculate B using the information, we have to use a Pythagorean theorem. We have to use the fact that c squared equals a squared plus b squared. And what we're trying to calculate is b, so we go b squared equals c squared minus a squared. So b is going to equal the positive square root of c squared minus a squared. And now we'll have calculated B using the given values and not using an interpreted value. So then I'll just substitute in D is going to equal the square root of C squared is going to be 15.3, that quantity squared, minus 4.8, the quantity squared. Now that's going to be as accurate as we can get because we're using given values. So second square root of, I think I can just do 15.3 and square it, minus 4.8 enter. Now there's two significant digits is the best I can do because this one is 2, that one's 3, right? So you can't, so all I can do is 15, correct? B equals 15. And it's not meters. Nope. Significant digits.
I just totally don't understand.
Of what?
Of significant digits.
Well, you will, it's how many digits you're using, and this thing has 2 digits that are using it. There's 2 significant digits in this calculation. This one has 3 significant digits. So when you're multiplying a number that has 3 with a number that has 2, the best you can do is do 2 significant digit number. If this were some number that had 3, if this had 4.81, it would have 3 significant. This would have 3 significant, so I could use 3 here.
How do you decide which digits drop or get dropped?
Okay, I didn't understand your question.
So you're going to simplify that into 2 significant digits instead of 3, correct?
Yeah.
Which digit do I drop?
You take the first 2 from left to right, except if it's a decimal. You know, if it's a decimal number, and if you have zeros that are holding placeholders only, then you start at the first actual number for significant digits. I'm going to go to and see, like, this is in response to your question. See, if you have something like this, 0, 0, 2, 3, 5. These 2 zeros are not significant because they just hold place for these 3. So I've had 3 significant digits. But if you have 1.00235, now that has 1, 2, 3, 4, 5, 6 significant digits.
So 3 significant digits on the bottom one would be 1.00.
Yeah. This is actually 6 significant digits right here.
Simplify it down to just 3.
Yeah, then you go 1.00.
So you only skip those placeholders if there's not a whole number on the other side of the decimal.
Unless they specify that these are actual. No, when they're just a decimal and then zeros, they're always placeholders. They're not gonna. But this makes it significant. But then if you were working these 2 numbers, doing some operation with these 2, and had some result, then this is 3 significant, this is 6, so you can only use the answer as 3. And then numbers like, I don't 100% do significant digits because when you get into your field, they're going to tell you what they want. But there's things like this. You could have 100, and if these 2 zeros simply give place to this, then it's only one significant digit. But if they say that the zeros are significant, then it has three. You know, if you went out and measured something and you measured 100 units and you said, you know, I am significant to the units place, then you have three significant digits. But if you were using a 100-foot ruler and you had 100, then you're only significant to one digit. You're only using one of those 100-unit rulers to show that it's 100 feet. But if you had a 1-foot ruler, you measured it off, then you're significant to all the digits. Because if it were 101 when you were measuring it, then all three of those would be significant. You used all three of those digits to say how many of those units you counted. And, you know, if they were 1-foot things, they went to 100 feet, so they're all significant. But if you understand, that's kind of what it's about. And if you don't understand significant digits, it's not going to hurt you in this class, because I'm not going to be that.
So if I don't round up from 14.5 to 15.
Yeah, I won't mark it down.
So you
Yeah.
also round your units to the significant.
I'm sorry, if you have two figures with the one significant digit after the decimal, you always keep it for what I always remember, because it's the same accuracy. It doesn't matter significant digits. If you have 10.2 and you have.
But you only have two significant digits.
And you have 15.4, you always go.
You know, and that'd be up to whoever is going to be in charge of your party. But you know, in terms of mathematics, it only has two significant digits.
I would go with decimal.
Yeah. Well, you know, I'm not going to count off on it, but if I were doing it, that's the way you'd have to do it my way.
No, that's why I asked.
But I'm not going to be that precise with it. Okay. Now then, back to what this is. Now, what we have to do is we have to calculate this angle. And then we have to calculate this angle, but we have to use this information. So, what I want to do is, what would be the use of these two values that I would use in the trigonometric function to calculate that? When you say to this angle, this side is what?
Opposite.
And this is hypotenuse, isn't it? No, adjacent's here. This is opposite. Hypotenuse is always, yeah. So what you have is you have opposite and you have hypotenuse. Now that trig function is what? Sine of that angle. So that is, this is the relationship you have to use, because you're using the information that's given. So then substituting into that, then the opposite would be 4.8. The hypotenuse would be 15.3. And then you do the sine of A. Now, A is what you want to calculate. So what you have to do is you have to do the sine inverse of this 4.8 over 15.3 is going to equal the angle A, the degrees that you have. Now, here's where you have to have it in degree mode, because if you don't have it in degree mode and you do sine inverse and you had it in radian mode, it'll give you the radians. So you'd want to make sure when you're doing this that you have that set. Is there any questions on what I did. So I'm going to do, I could turn it on. Second, sine inverse. See, and I get that sine inverse. So you got to go 4.8 divided by 15.3. Now this is 18.283839 degrees. And what did it say we had to do this in? Degrees, minutes, and seconds, because it says when two sides are given, give angles in degrees, minutes. So this is only in decimal degrees. You got to convert that to degrees and minutes. That's what that is telling you to do. So then what you have to do is you have to say 18 degrees plus 0.2838 degrees. Now how are you going to convert that to minutes? There's 60 minutes in 1 degree, right? And notice the units will cancel out degrees. So when you take 0.2838 times 60, it'll give you the minutes. So I go 0.2838 times 60. And it's 17 minutes. So this is 18 degrees. $17. Now there's a decimal point 02, but it says 3 significant digits. So if you go back, or 2, whichever way you want to do it, notice it says if you're doing 3 significant digits, you could only go to the nearest 10. So I'm not going to be any stickler on this. If you followed what Chris was saying, then what you do is this thing would be 18 degrees 20 minutes. If you follow what I say, then it's 2 significance and you'd only have 18 degrees. It'd be whatever the people that you're working for or your teacher in your program tells you to do. That's where you got to do it. Because I will take this thing right there. Because I want to know that you know how to do the conversions. Because if I start telling you that this is the way it's got to be, and I'm going to grade you off for it, then you're going to go to another class, and I'll tell you what, you'll go to classes, and every class will be different. They will tell you a different way that you're going to do it. And you'll go out into your job, and they'll tell you another way you're going to do it. And you might always round up, and you might always round down, and you might always do whatever it is. I don't know. They just have, everybody has their own way, but they want it done. Now, notice that we have this angle. So for the purpose of what we're talking about, where it's 1817, that's what we'll go with. This one is 18 degrees, 17 minutes. Now, we got to calculate B. To do it the way the book is telling us to do it, what are we going to have to do? The temptation would be to take 90 minus that. Is that the way the book says to do it? The book says using only the information that's given, which is these two, right? So now, once again, this to this angle right here, this is what? Adjacent and hypotenuse, right? See, we're trying to calculate this angle. That's adjacent and hypotenuse. And I'll do it in green. So to the angle B, what I have is I have the adjacent side and I have the hypotenuse. Now, what trig function is going to relate the adjacent to the hypotenuse? Cosine. Is that clear? You just have to figure out what it is, and that's so then then what I'm going to have to do is just like this thing, to find the angle B, I'm going to have to do the cosine inverse of this, right? The angle at B is going to be the cosine inverse of the adjacent over hypotenuse. And so now I'm going to put numbers in, get cosine inverse. And the adjacent is 4.8 over 15.3. And whatever that comes out to be, that's going to be that angle at B. So I'll go second cosine, that's cosine inverse. And that's 4.8 divided by and now that's 71.7161 degrees. And now what I got to do is I got to go 71 degrees, and then I have to take this 0.7161 times, and that's degrees, times 60 minutes over 1 degree. So I'm going to go to 7.1. And now I'm going to have 42, and I guess I don't really care if you call it 42 or if you call it 43.
Why do you keep going down to the minute or the seconds?
If you went down to seconds, then what you'd have to do is that 0.988 that's there, 966, you'd have to multiply that by 60 seconds in 1 minute.
That's
And then you would get seconds. And then you'd have a decimal there, and then you'd have to decide if you're going to drop the decimal off the seconds or not. But in order for what I always do, you don't have to. I always do this unit conversion thing so that I can see that I'm canceling my units. See, because I'm saying there's 60 minutes in 1 degree. Because if you were going from degrees to seconds, then you'd want to go 60 times 60. You'd want to go 3,600 seconds in 1 degree. And then you could convert straight from degrees over to seconds. But then you'd remind yourself of what you're doing. I think it's just safer to do the unit conversion. And this is B. Now, the significant digits is not the important thing. The important thing here is that you use the given data. And the given data are those two sides to do all your calculations. Because then you're going to be as accurate as possible. So then in order to calculate this side, you have to use the Pythagorean theorem. You wouldn't calculate this angle and then use the cosine of that angle to get B, like doing adjacent to hypotenuse. Because then you have one rounding error in the problem right here. And then you get another rounding error when you get your answer for B. You'll see why they don't want you, they want you to use this, the data that's there. And that's just a good practice when you're in the field, is don't use intermediate calculated values to do final answers. Use the given stuff. Or else, if you're going to do intermediate stuff, is put everything in your calculator, everything in your problem all at once. Don't do an intermediate step, round it off, plug it into the problem, and then do an intermediate step, round it off and plug it in, because you can get multiple rounding errors, and that can get you really off. You know, if you're having to find the sine of an angle which was given to you and you just having to use that calculated value to find something else, and then you'd have to use that calculated value to put something else, then put all that in nested form. You understand what I'm saying? Just put it all in a problem, nest it, and then enter it all into your calculator once. And then what you do is the calculator will calculate all those nested parts to the most units it can, and then it minimizes the rounding error. That's just a good practice for you in the field. So you want to kind of understand your algebra in terms of nesting problems. And in that particular case, that's where Excel can be really advantageous, because you can do cells, right? And then you can do those cells, and it'll just nest it, and it'll calculate everything out to the maximum you can, and put your values in, and then you get, and then make sure your cell is going to be taking it out as far as it can. All right, so if there are no questions on those problems, let's look at the next set. It says solve each. I'm looking at the problems 21 through 36. Solve each right triangle. In each case, C is 90 degrees. If angle information given in degrees and minutes, give answers in the same way. If given in decimal degrees, do likewise in answers. When two sides are given, give angles in degrees and minutes. Same kind of instruction as previously. So they're going to suggest that what you do is you draw a picture and put the information into that. Now I'm going to draw a right triangle. The right triangle may or may not do anything other than, it might not be in scale when we get done or anything like that. It's just a way to establish what I'm doing. Now I don't know really the length of the sides, so I don't know. But I can kind of figure out if this is A, this is B, so C is 29.7. Now, if they give me B is 46 degrees, then A is going to be 90 minus 46. I really have this labeled backwards for perspective's sake, right? I should label B down here and A up here, because A is the bigger angle. So I perhaps should relabel this just for the sake of having it look a little bit right. Put A up here put B down here because they're giving me that this angle is 46.0. Now, you see what they technically given me. They've given me this angle, and that side, right? So I can calculate A to as accurate as it's possible to calculate it by simply subtracting 90 minus 46, right? Which is 44. I actually had it right before. This is the smaller angle. I was subtracting my head wrong. I'm not going to change it now, but somehow I had this 54 because so it isn't quite going to be in perspective. So I've calculated this value. This is given to me, and I can do this as 0.0 because that 0 is significant. Now what I want to do is this B I do not know, and that A I do not know. Now what I know is I know this angle, that side, which is the hypotenuse. If I want to do A, then I have adjacent, I have hypotenuse, and an angle. So what's that going to be? What trig function? Sine, cosine, or tangent? For A. In relation to angle B, A is what? Adjacent. And 29.7 is hypotenuse. So what trig function am I going to use? Cosine. I'm going to use cosine of 46.0 is going to be, and it's adjacent over hypotenuse, right? So I'm going to put the adjacent is A, and the hypotenuse is 29.7. So when I calculate A, I'm going to multiply 29.7 times the cosine of 46. And that's going to give me A. You see why? I mean, I'm trying to say the information that is available, and when I'm trying to calculate something, I got to figure out what trig function I'm going to use. So now I'm going to go 29.7, and then I'm going to go cosine 46. Now I don't have to worry, put the decimal in there, it'll just calculate it out. So 20.6 would be so this now I want to calculate B to this angle. This little b is what? The angle B. B is what? What side? Opposite, right? And then the other thing I know is the hypotenuse, right? Now, what trig function am I going to use? I'm going to use sine. I'm going to use the sine of 46 and opposite is going to be B, and hypotenuse is 29.7. So I'll go 29.7 times sine of 46. That's going to equal what my B is. So that's going to be, and I'll round that off to 3 digits, 21.4. And now I have everything, I've calculated that side, 21.4. I've calculated this side, and I've calculated that angle. So I've got everything calculated that I need to. I don't think I have. Well, I'll talk about 32 and what time we have remaining. So this is always C, this is little c. I'll just go A and B. This is going to be little a and this is going to be little b. Notice that they've given us 219. So this whole triangle is going to be totally out of perspective. And then they've given us, well, C, I don't know this shit, 647. So what are you going to do? Using the information you're given these two sides. For A, you're going to use the Pythagorean theorem. So you're going to use the C squared equals A squared plus B squared. Isolate the A. And it's going to be the positive of the square root there. Right. Putting my values in, I'll go 647 squared minus 219 squared, and that's going to give me whatever this is, right? Now I have to calculate this and this. So if I'm doing this angle, what trig function am I going to use? The cosine, because it's adjacent on hypotenuse. If I'm calculating this angle, what am I going to use? Because it's opposite hypotenuse. All right. And then because these things, then the angles when we get it, because I'm given two sides, I'm going to get a decimal degree, and I got to convert it to minutes, the degree to minutes. Just like I did in that previous one that was given that way. All right. Okay. We can look at section 2.5 next time. If you have questions on any of the problems,